Hey everybody, how's it going? Hope everybody has had a great week. All right, happy Friday. And hopefully I'll be able to see everybody next week. But before that, let's get going on today's stuff. So we got adding and subtracting all kinds of fractions. This time they are going to be uncommon denominators. So I'm going to try and show you guys a couple examples of each type. So these guys over here are proper fractions. These guys are improper fractions. And then we got mixed down here. So in order to add or subtract fractions, you need common denominators. So I'm trying to have you guys take whatever's going on over here and regroup it in this little situation so it's a little bit easier for everybody to work on these things. So once we rework it from here to here, you can just go from here over. Forget about all this mess. But in order to get there, we got to find some kind of common denominator. So you could multiply 15 times 10 and do 10 times 15. All right, you could do that, but sometimes that is going to be the easiest one and the first one that they have in common. But in a situation like this, that's going to give you 150, and there is lots of common ground before you get to that point with these guys. So the first thing that these guys have in common, the first number, is 30. All right, and what you got to do is multiply 15 times 2 to get you 30, and then 10 times 3 to get you 30. So remember, when you guys get the common denominators, that's important, but whatever you do to the bottom, you also have to do to the top. That's what keeps those relationships the same kind of like value and balance. All right, it'll make a little bit more sense once I get down here to this one, because 1/2 is always easiest to talk about. But whatever you do to the bottom, you got to do to the top. So this one was times 2. You got to do 11 times 2 here to get you 22. And this was times 3. You got to do 7 times 3 to get you 21. Now these guys look like this. It's the same, they're saying the same thing, just different sizes. But now we can work with these ones because they have common denominators. So 22 plus 21 is going to give you 43. And remember, the denominator stays the same. But since this is improper, all right, we can make it into a mixed. It's nicer. How many 30s can you get out of 43? Just the one. And then how many is that left over? 13 out of 30. All right, let's come down here to this one. Oh no, it's subtraction. What do you do? We still got to get the common denominators. We can't do anything yet. So sometimes you'll have to change both like we did in the first example. But with this one, don't have to. The first number that these guys have in common is 8. So we only have to change this one. So 4 times 2 is going to give us that 8, and then the other one already is 8. So we're off and done with those ones. But since we did this times 2, we got to do times 2 on the top here. So 18 times 2 is going to give you 18, and then this one didn't have to change at all. That minus 11 eighths just stayed 11 eighths. All right? So 18 minus 11 is going to give you 7. And then the eighths still stays the same. So that is our answer for this one. All right, and then here's what I was talking about with that other one. All right, sometimes the first number that they have in common is just those two numbers times each other. And that's exactly the situation here with these guys. The first number that they have in common is 10. So 5 times 2 is going to give you 10, and 2 times 5 is going to give you 10. And remember, whatever you do to the bottom, you have to do to the top, but you're not doing anything to the whole numbers. Those guys are on their own little world there. So 3 times 2 is going to be 6, and then this 1 times 5 is going to give you 5/10. So remember, like what we were talking about before, what you do to the bottom, you do to the top. What you do to the top, you do to the bottom. That's what keeps the relationship the same. You're starting off with a half, and now you have 5/10, which is another variation of a half. It's the same thing, just different size. If you just did 2 times 5 and had 1/10, that's not a half. If you just change the top, 1 times 5 will give you 5/2. That's not a half. You got to do it to both to keep that relationship of a half the same, just saying it in a different way. All right, so now that I just reviewed that, let's bring these whole numbers over here, and now you can do the problem. All right, 6/10 minus 5/10 is going to give you just 1/10. And then 7 minus 3 is going to give you 4. And let's just do one more example here of each. This time, we have to pay a little bit more attention to the signs. All right, but before we do that, still need that common denominator. That's the thing we got to do first. So the first number that these guys have in common, this is again another one of those where you're going to multiply them by each other. So 5 times 7 is going to give you 35, and 7 times 5 will give you 35. But whatever you do to the bottom, you got to do to the top. And remember, keep an eye out for those signs. All right, this is a minus sign, which just comes over. So you're just working with that 6 there, not a -6 when you're changing things around. But this one is a -2 because it's right there with it. So you got to do -2 times 7, get -14 over there. The minus sign comes over, and that's going to be 6 times 5, which is 30. All right, now that we have common denominators, now you're viewing this as a -14 and a -30. Same sign, keep and add. So 14 plus 30 will give you a -44, and then over the 35. So since it's improper, we got to make it into a mixed. How many 35s can you get out of 44? Just one. But remember, since this is a negative, that's going to be a -1 there. The sign gets put with the holes, and then these guys can be just regular numbers. So if you pulled out that 35, how many do you have left over? 9 out of 35. There you go. Can't do much better than that. All right, with this one, the first number that those guys have in common is 9. So we don't have to change that one, but we do have to change this one. All right, 3 times 3 will give you 9 there. So now we got those 9s. The -13, it's good to go. But we got to change this 12. Got to do 12 times 3 since we did the bottom times 3. So that's going to be 36. So we got a positive 36, but a -13. All right, so the guys are opposites. Got to subtract. So 36 minus 13 will give you 23. There's more positives, so it's a positive 23 over 9. So how many 9s can you get out of that 23? 2. With how much left over? 5, and then the denominator stays the same. All right, and then this last one, let's get these denominators the same. Let's get some common ground here before we start attacking the problem. So these guys have, 24 in common, 36 in common, 48 in common, lots of numbers in common, but the first one that they have in common is 12. So in order to get there, we got to do 6 times 2 will give us that one, and 4 times 3 will give us that one. But remember, whatever you do to the bottom, you got to do to the top. So 1 times 2 will give you 2 there, and 1 times 3 will give you the 3 over there. And remember, the whole numbers just swing over. All you got to do is change the fraction parts. So this is -2 and 2/12, and this is -6 and 3/12, or -6 and 3/12. So same sign, keep and add. So since these guys are both negatives, we're going to add them up to be a larger negative over here. So 2 and 3 are going to come together to give you 5/12. -2 and -6 will come together to give you a -8. So remember, these guys are both negatives, but you only need the sign on that one over there. All right, so there's a couple of examples for you guys. Remember, these videos are here to try and help you guys out. So if you need to, you can go back and rewatch any kinds of examples here. The proper ones, improper, or the mixed. All right. Have a happy rest of your Friday. Have a great weekend. and I will see you guys on Monday. Have a good one, everybody.